Yeah, so let's start with our session today. Welcome to week 6 session of the this particular NPTEL PMRF teaching assistantship session, which is basically an additional session which are meant to interact with our learners. This particular course is known as the Geotechnical Engineering 2 Foundation Engineering, which is currently being tutored by Professor Dilip Kumar Bedia, who is a professor in Department of Civil Engineering from IIT Kharagpur. So those who are joining this session for the first time, let me tell you, these sessions are meant to interact with our learners. We'll be discussing some of the important concepts which will be required to solve your assignment problem. Along with that, we'll be solving some of the sample questions. We'll also be solving some of the doubts solving session, and along with that will be, if you are having any other query related to the course or let's say for the session, please feel free to discuss. Let's start with our session today. So the first question which is in front of you, the type of the seismic waves typically used in seismic reflection test is slash R, whether it's a long waves, surface waves, body waves, or all of the above. So this is a question in front of you. You are meant to ask what is the type of the seismic waves is typically used in the seismic reflection test. So you can ping your answer in the chat box, and within 2 minutes we will discuss that. So let's check the answer. The correct answer is C, body waves. Let's see how does it work. So let's say if this is a soil layer which is there in front of you. So let's say if a single ray strikes the bottom of the soil layer, and if it gets reflected by a certain amount, and Also there will be this particular way, surface way. So in the type of the seismic, for the seismic refraction, we'll basically utilizing the waves which will be passing through your soil layer and striking back to the bottom of the soil layer, and again detected at the another GFO. So this total distance traveled and the time required to travel this distance will be basically utilized to determine the properties of the soil and the thickness of the soil layer. So yeah, the correct answer is the type of the seismic waves typically used in the seismic refraction test is a body waves. Question number two. Uh, the soil that has the highest resistivity from the following option is a. So any doubt in first question? If not, so let's move to the question number two. The soil that has the highest resistivity from the following option, whether it's the number of flows, cone resistance, effective stress, or none of the above. Please select one of the options. So let's check the answer for this. So soil that has the highest resistivity from the following option is our A, B cone resistance. Let's move to question number three. For a soil deposit with an angle of internal friction phi, the earth pressure coefficient in active case K is. So we need to determine the earth pressure coefficient for the active case K. So let's check the answer. So the earth pressure coefficient K is none other than your 1 minus sine phi upon 1 plus sine phi, where your phi is the internal friction angle. Moving to question number fourth, you need to determine among all four of these in which system we basically utilize the internally stabilized soil system, like among all the four. So let's check the answer for this. So the correct answer will be reinforced earth retaining walls, retaining nailing. So let's say if you are having a retaining wall, so let's say if you are having a retaining wall, yeah. So the entire, so usually for the gravity retaining wall, we know the uh, external pressure is being resisted by the gravity of the retaining wall. While with the cantilever wall, again, it's basically the uh, available hang length available for the cantilever. Uh, but for the reinforced earth retaining wall, it basically utilizes the nailing system, which is basically connected to the gravity wall, and with the help of the internal friction between the soil and the nail, the basically the overturning of the wall has been restricted, and that basically prevents the movement of the soil behind that, and that's why we can say the reinforced or retaining nailing basically prevents the movement of the soil. So yeah, the correct answer is option B. Yeah, that was the thing. Okay, moving to question number 5. Okay, it has been hanged. So let's check the answer for this. So the correct answer is option B, the reinforced earth retaining. Moving to question number 5, the lateral earth pressure coefficient of a soil, Ka for active state, Kp for passive state, and K naught at the rest condition. Then you need to select what is the correct relationship between the Ka, Kp, K naught is. So among all the 5, basically you need to understand, you need to select which relationship basically resembles the correct relationship between the Ka, Kp, K naught. let's check the answer for this. So correct answer is option D. So your K is equals to 1 upon K. Rest K naught. This is not the relationship between the K naught K and KP. Again, this is also not the relationship between the K minus KP by 2, K plus KP. So that's all the difference. Moving to question number 6. So you are having a retaining wall with a vertical bake retains a cohesionless dry backfill at an inclination of phi with the horizontal. The backfill has an angle of internal friction angle phi. The coefficient of the passive earth pressure Kp on the wall is given by. So let's check answer for this. So in this case, if you are having a retaining wall, so there will be some soil which will be having this particular slope above the top of your retaining wall, and it will be having the inclination angle of I, and of course the soil property here we are talking about is the phi. So here basically we need to determine what is the coefficient of the passive earth pressure, which is given by Kp. Check the answer. It's option C. Is your cos I plus cos I whole square minus cos phi square upon cos I root over cos I square minus cos phi square. So that will be the answer. So yeah, option C will be the correct. Moving to question number 7. What will be the correct expression for electrical resistivity of the soil material rho is A is equals to 2 pi dV, B rho is equals to 2 pi dr, C rho is equals to 2 pi dV by r, or D rho is equals to 2 pi di by. Please select one of the option. So let's check this. So usually in this arrangement, like if let's say if you are having a soil layer, so let's say if you are having four electrodes, then among these four electrodes, the two outer electrodes will be utilized to supply the current, while these two electrodes will be utilized to measure the voltage. So the resistivity of the and this D is basically your spacing between the electrodes. So usually the resistivity, which basically also utilized to characterize the soil, is given by 2 pi spacing between the each electrode and the resistance. So the correct answer is option B. Moving to question number 8 to 9. You are having a retaining wall with a smooth back retained sand backfill for a depth of 7 meter. That is, the height of the wall is the 7 meter. The backfill has a horizontal surface and the gamma W of that particular soil material is 9.81 kilometer per meter cube. You need to basically utilize the Rankine theory, and then you need to calculate what is the total active thrust on the retaining wall is. So let's say you are having a retaining wall is having a sand backfill of, let's say, 7 meter depth. Okay, the height of the wall is 7 meter, and okay, it's not necessary, it's a gravity wall. So this is the wall. Total height is 7 meter, and then you are having a backfill. Okay, backfill is also of total 7 meter. The backfill has a horizontal surface. Let's say this is the horizontal surface, and your gamma W is equals to 9.81 kilonewton per meter cube. Then basically you need to utilize the Rankine theory to calculate what is the total active earth pressure is. So how much is your total active earth pressure thrust? Okay, the figure is not given to you. I'm sorry for that. So this basically the figure, basically looks something like this. So if I just mark what is the figure, so this is your retaining wall. This is basically your water table. This is of your 3 meter depth, and this is of your 4 meter depth. Here this is your sand, gamma dry, which is your none other than 17 kilometer per meter cube, and your 5 is 25 degree. Another layer of your soil is this, and having a sand. Your gamma saturated is 22 kilometer per meter cube, and your phi is none other than 25 degree. Okay, so basically we need to evaluate the backfill pressure. So we need to evaluate the passive earth pressure, so the total active thrust. Okay, so let's check the answer for this. So first we need to draw the stress diagram. So if we see the stress diagram, so this is your retaining wall, and this is your bottom of the retaining wall. So here till here your density of the soil is different, above your density of the soil is different. So let's say at the bottom it's 4 meter, and then it's the you are having a 3 meter. So first I need to calculate how much is the stress has been applied by the soil. So your stress diagram something looks like this. And then your another stress diagram below this will something looks like this. and then you'll be having the hydrostatic force, which basically look like this. So basically this is your this thing, Ka gamma h, and K gamma h1, gamma 1 h1, this is again your K gamma 2 s2, sorry, this is your K gamma 2 s2, and this is your K gamma 1 h1, and then this one will be your gamma w s2. So that is the particular thing. So now we need to calculate the area of this stress diagram to basically evaluate how much is the total active thrust acting on the retaining wall. So total active thrust, if I'll check, is basically something look like this. So this will be your half K gamma 1 h1 square this will be your K gamma 1 h1 into s2, then this will be your half K gamma 2 s2 square plus gamma w s2 square. So that will basically give you how much is your total active earth thrust. Okay, so if we'll just see this, okay, so first we also need to evaluate this, so I'll just add a sheet for this. Okay, it was there but it can't display. So first evaluating this. Okay, So let's check the answer for this. So this is your basically retaining wall. Okay, it got hang again. Okay, let me explain you through my solution sheet only in this case. Okay. So yeah, uh, if you see this, so that is basically the solution. So that's how somewhere our stress diagram basically looks like. So I'll just check whether I'm having this. No worries, I'll move with the cursor. So first you are having the K 1 minus sin phi upon 1 plus sin phi. You will basically calculate K since both the layers are having the similar friction angles, so you will be having the similar K. Then for the P1 you are having the half K gamma 1 H1 square. Then for the P2 it's K gamma 1 H1 S2 because this is K gamma 1 and this is S2. And then P3 this is K gamma 2 minus gamma W because here your water table is available into H2. This is your S2. And for the P4 it's basically half into gamma W. So basically you are evaluating how much is the hydrostatic force which has been applied to the this layer. So you will basically solve this. So PA P1 plus P2 plus P3 P4, and that will basically give you the correct answer, which is none other than is your 231.57 kiloton, which is your closer to 232 kiloton. So that is the correct answer. So I think you got this. Let's move to next question, which is your sorry. Open. So moving to question number this. So you are having a retaining wall which is having a smooth back with retained sand backfill for a depth of 7 meter. It's having a height of 7 meter. The backfill has a horizontal surface and a gamma W of 9.81 kg per meter cube. You need to use the Rankine theory to basically evaluate the line of action of active thrust on the retaining wall from the top. So this basically gives you how much uh, load which has been resisted by the retaining wall. So you are having a this thing which is your none other than you are having a stress diagram which you have already seen, and then you need to basically counterbalance the forces to evaluate the line of action. Just see the question, give it a try, we'll check within 5 minutes. Yeah, so let's check the answer. The answer is 4.94, and let's see the solution for this. So we have already evaluated the P1, P2, P3, P4, right? So it's 30.98, 82.62, and 39.49. And now we just need to see like where all these forces are acting. So for the P1, we know it's a triangular stress diagram, so it will act at the height of 1 by third above its base. For the P2, it will be half of its height. P3, again it will be one third from its base, and P4 again it's from one fourth of the base. So that's how basically you can do this. So considering this is the point of reference, so this is your this thing P1. So if you consider from the top, it's basically 2 by 3 of your 4, 2 by 3, then again 2, yeah. So that is how it basically looks like. So in here we have taken 2 into 30.98, basically 3 plus 2 by 3. Okay, we are considering from the top, again 3 plus 2 by 3 by 4. Okay, so these are the total force P1 plus P2 plus P3 plus P4. So correct answer is option B, 4.9. So moving to next question. Question number 10. You are having a non-cohesive backfill which is written behind an 8.5-meter tall counterfort wall. The void ratio in the internal friction angle are 0.53 and 40 degree in dense condition. The specific gravity of the soil is 2.71 and gamma W is 9.81 kN per meter cube. Then the passive earth pressure on the wall is. So what is the passive earth pressure on the wall? So it's 136, 1453, 2357 or 2886. So let's check the answer. So answer is your 2886. Let's see how it is. So it has been given that is you are having a non-cohesive backfill which is written behind an 8.5 meter wall. So this is your 8.5 meter wall basically. The void ratio intersection are 0.53 and 40-degree in dense condition, and the specificity of the soil is 2.71 and the gamma W is given to you. Then you need to evaluate the passive earth pressure. So again the Kp value you can calculate with the help of this 1 plus sin phi upon 1 minus sin phi, and with the help of the given other parameters, soil parameters, you can basically calculate what is the gamma. Once you can calculate this, you can evaluate how much is the passive earth pressure, and then you can evaluate what is the how the passive earth pressure basically looks like. So this is your answer, which is 2881.84 kilometer, which is your closer to 28886. Moving to question number 11. So you have been asked in a crosshold test, the trigger and the geophones are 10 meters apart. After basically the impact, the arrival time of the SV wave at geophone is 10.5 meter second. What is the velocity of the SV wave is? So this is a question. We are having a crosshold test. The trigger and the geophones are 10 meter apart. After the impact, the arrival time of the SEO at geophone is 10. You need to evaluate what is the velocity of the SV wave in meter per second is. So let's check the answer for this. So that is how you will basically deal. So here is the diagram in front of you. You are having the trigger and then you are having a geophone. First you will basically transfer the wave from trigger to geophone, and then basically you can calculate what is the velocity, which is the displacement upon time. So the displacement, total displacement is given to you, which is the 10, and then the time is given to you, which is the 10.5 meter per second. And that's how you basically calculate the velocity, which is your 10 upon 10.5 into 10 to the power minus 3, which is none other than 952.4 meter per second. So the correct answer is option D, 952.4. Moving to question number 12, you are having a shear vein which is of the 75 diameter. You are The total length is 125 which was placed into the soft clay at the bottom of the borehole. 45 newton meter torque was applied at the failure of the soil occur. Considering resistance from the top and the bottom, what is the undrained shear strength of the clay soil is? So let's check the answer. The correct answer is 34. And how is it solved? So I'm having solution of that also. So that's basically how you can evaluate the undrained shear strength with the help of the torque available. So you will be having an applied torque, and then this is divided by pi d square into h by 2 plus d by 6, and then you can evaluate how your undrained shear strength basically looks like. So this is your SU formula: 45 pi d square 0.125 by 2.076, and then how that's your SU is, which is the 34 kilopascal. So moving to the next question, the maximum depth of excavation that can be made in the saturated soft clay having cohesion of 30 kPa, friction angle of 0, and the gamma of 20 kN per meter cube without any lateral support. So how much the total depth we can go for? let's check the answer for this. The correct answer is option C, which is the 6. So let's check the solution. Yeah, so usually the maximum depth of the excavation that can be made in the such a soft clay having C 30 kp and phi equals 0 degree and gamma equals to without any lateral support can be calculated this h equals to 4c upon gamma root underscore ka. 4 is given to you, c is 30 kpa, gamma is your 20 kN and underscore root k, which you need to value. So the correct answer which will you get without any lateral support, h equals to 4 into 1.5, which is the 6 meter. So yeah, I think that's it for today. Those who will be joining watching these videos at the later session, I request you please post your comment queries in the comment section. I'll definitely address there. And I request you to please join the live sessions usually held on Tuesday, because since I was traveling uh, on the last Tuesday, so the session could was not held at that time. But yeah, from upcoming Tuesday onwards, it will be regular. So I'll request you to please join session at that time. And thank you so much.